thermal properties of matter, heat capacity and specific heat capacity, Charles law, and many more in this video. If you are new to my channel, I request you to subscribe, and we are beginning from here. That heat is a form of energy that passes between bodies which are at different temperatures. Remember this. What is heat? A form of energy which passes from between bodies which are at different temperatures. The law of conservation of energy states that energy cannot be created nor destroyed. It follows, therefore, that when we heat or cool an object, the internal energy of its particles must increase or decrease. A change in temperature is a measure of a change in the internal energy, random thermal energy of an object. Alright, heat capacity. What is heat capacity? Now just listen carefully. If aluminium and copper blocks of the same mass or copper blocks at sorry copper blocks of different masses are given the same amount of heat energy, their temperatures will rise by different amounts respectively. For suppose I have take two blocks, one of aluminium block and another is of copper block, both of the same masses, as suppose 10 gram, and also have take the third block which is having same material of made like copper block but of different mass, now 20 gram. So that for suppose that if I have given the energy amount of heat energy to these three whatever the objects are, the temperature will rise by different amount respectively. So just understand what is heat capacity is trying to make you understand about. Meanwhile, heat capacity depends on the mass and the material of an object, as heat is form of energy measured in joules. Heat capacity is measured in joules per degree Celsius or joules per K means Kelvin. What does degree Celsius in Kelvin means? Kelvin or degree Celsius means the SI unit of temperature and is represented by symbol of capital C. Okay. Heat capacity is the amount of energy needed to rise the temperature of an object by 1 degree Celsius or 1 Kelvin. Heat capacity can be expressed in terms of heat energy absorbed or given out. The Q means heat. Heat energy means Q for a given temperature change means delta T. What does delta T? Delta T means change in temperature. Meanwhile, the final temperature minus initial temperature. What we understand in the range? Maximum minus minimum. Here, the maximum temperature minus minimum temperature or the final temperature minus initial temperature is equals to temperature change. What is the formula for heat capacity is basically what you are required to learn. Capital C represents heat capacity is equals to Q upon delta T. Here the Q means heat energy, how much heat has been supplied, the amount of heat energy will come at the point of Q. Delta T upon delta T means the change in temperature. What is specific heat capacity? It isn't possible to say that objects made of one material will always have a greater heat capacity than objects made of another material because the objects may have very different masses. Indeed, obviously this is very easy to understand. In order to be able to make a meaningful comparison between the heat capacities of different materials, we need to compare equal masses. This is necessary. In other words, to compare heat capacity per unit mass. The specific heat capacity of a substance is the amount of heat energy required to raise the temperature of 1 kilogram of that substance by 1 Kelvin or 1 degree Celsius. Alright, the symbol of specific capacity is small t. Now, what is basically essential for you is the formula of a specific heat capacity, which is small c is equals to capital C upon M is equals to 1 upon M bracket open Q upon delta T bracket close. This is the overall formula, the complete formula. The small c means the specific heat capacity. Capital C means the simple heat capacity upon mass. M means mass. And what does mean by the Q means heat energy, and the delta T means change in temperature. Latent heat. The particles in a solid cannot move about but are held in fixed positions. As the solid is heated, the particles vibrate more and more vigorously until they have sufficient energy to move away from each other and the solid melts. Up to the point where a solid melts, the heat energy increases the temperature of the solid, but when the solid melts, the temperature no longer increases. The heat energy is used to overcome the forces of attraction between the particles. This energy is called latent heat of fusion, and is given the symbol of L. And you can see now the F is written in very small size. It means that the capital L, remember capital L, and whether the capital F or small f, but will be written in the small size. This will be represented by latent heat of fusion. Latent heat of fusion or vice versa without change in temperature. Alright? It means you are required to not change the solid towards the liquid or the liquid towards the solid without change in temperature. Similarly, the latent heat of fusion of an object depends both on its mass and the material it is made of. Alright, so took an example here. Just wait a minute. Alright, so there is an example. An ice cube and iceberg are both but the latent heat of the iceberg would be much. A similar situation arises when a solid begins to boil. The energy needed for the particles in a liquid to overcome forces of attraction between each other and become a gas is called the latent heat of vaporization and is given the symbol of L, and again in a small size it is V. Alright, so you can understand by this the you can now understand that L means means of fusion. What does here means? Latent heat and V of vaporization. Okay, so taking another example, latent heat of vaporization of a liquid is the energy needed to change the liquid to a gas or vice versa without any change in the temperature. Now, here is another thing. Now the name of the matter has been changed from the solid to the liquid, now to the liquid to the gas. From the liquid to the gas or the gas to the liquid without any change in temperature means latent heat of vaporization. The latent heat of fusion of an object Lf can be expressed in the terms of its mass m and the specific latent heat of fusion of the substance from which it is made. LF is equals to M multiplied by LF. Now you can see that what is mean by LF. It is now the small l and then F. The substance of specific latent heat of fusion. Do you understand? The capital L and small f means latent heat of fusion. Simply latent heat of fusion. But here M multiplied by small l and f. What does small ln f means? Specific latent heat of fusion. That was latent heat of fusion simple, and this is specific latent heat of fusion. So this is the formula for the heat fusion. Specific latent heat of vaporization is treated in the same way. Specific latent heat of vaporization of an object can be expressed in terms of its mass and the specific latent heat of vaporization of the substance from which it is made. The formula is L, the capital L and V is equals to M multiplied by small l and V. What does small l and V means? Here, small l and f represents latent heat. So here, small l and v means at the last, m multiplied by small l and f. The small l means specific latent heat of vaporization, and the capital L and V at the front of the formula is mean by only latent heat of vaporization. So the word included specific makes the letter small. This is the trick you can just remember while solving the paper. Okay, thermal expansions of solid, liquids, and gases. In general, all solids, liquids, and gases expand when heated, but not to the same extent. This is what we know already. In our junior classes, we have already acknowledged that when a solid, liquid, or gas are being heated, they are does not being expand to the same extent. Alright, expanding solid. Solids expand by the smallest amount when heated. Both metallic and non-metallic solid expand when heated. Large large metal structures like bridges expand in hot weathers. One end of the bridge is fixed while the other sits on the rollers so the bridge can expand without buckling. Alright. Similarly, railway lines expand in hot weather, so a small gap is left between sections of line to allow for expansion. In the early days of railway, engineers did not acknowledge about this, and trains were derailed when the lines buckled. Overhead power lines are always erected with a small amount of sag to allow for contraction in cold weather. Alright. Expansion in liquid. When liquids are heated, they generally expand more than solids. We know why it is because the solid particles are. Yes, and because of the liquid particles are. If you does not know about this, so just watch my previous video where I have already talked about the particles of matter, which is very foremost essential for you. If you have not visited, visit that. Okay. When liquids are heated, they generally expand more than solids. You should recall from chapter number 9, temperature. If you have not watched the video, you can go through the excellence icon and just also visit that video of temperature where I've briefly, detailingly describe about whatever was about for the temperature and the thermal properties. It is not possible to measure temperature using a thermometer because the liquid in a expands as it gets warmer and the level rises up the capillary tube. This is what you are familiar with. Expanding gases. Okay. Gases expand far more than solids or liquids for the same increase in temperature. We know this what is the reason basically for which the gas expand more than solid and liquid? We all know. If a flask of air is connected to a U tube containing a colored liquid, the levels of the liquid in the two arms of the tube change as the air is heated. Alright, and at the last we are here for understanding the Charles law. What is Charles law? The internal energy of the particles in a gas depends on its temperature. If the temperature increases, the internal energy of the particles also increases. This, in turn, leads to an increase in the distance between particles. Charles' law states that for a fixed mass of a gas at constant pressure, its volume V, volume stands for, volume symbol is V, is directly proportional to its absolute temperature, T. Alright. In science, we often measure temperature on the Kelvin scale. This scale begins to at absolute zero. Since the graph is a straight line that passes through the origin, when the temperature is expressed in Kelvin, we write a mathematical expression which is known as Charles law. Okay, what is the mathematical expression which describes the Charles law basically is that V is directly proportional to T, means volume is directly proportional to T. Therefore, V is equals to constant multiplied by T. Obviously, therefore, V upon T means volume upon time is equals to constant if the pressure remains constant. Okay. Key points to remember. Heat is a form of energy and is measured in joules. Heat capacity is the amount of energy needed to raise the temperature of an object by 1 degree Celsius or 1 Kelvin. The specific heat capacity of a substance is the amount of heat energy required to raise the temperature of 1 kilogram of that substance by 1 degree Celsius or 1 Kelvin. The latent heat of fusion, LF, of a solid is the energy needed to change the solid to a liquid or vice versa, means from a liquid to a solid without any change in temperature. This is the same with the specific latent heat of vaporization. In general, all solid liquid and gases expand when heated. When heated, solid expand least and gases expand most. There are a number of important implications of the expansion of solid, liquid, and gases with temperature in everyday life. Water expands in an unusual way and has a maximum density at 4 degrees Celsius. Charles' law stated that for a fixed mass of a gas at constant pressure, its volume V is directly proportional to its absolute temperature T. So that's all. If you are having still confusion, you can comment me below. Until that, take care. Thanks for watching.